Now let's look at some expressions that use Boolean operators. Sometimes our decisions are based on the answer to more than one question. We can think of each of the relational operators that we apply as answering a single question, like is the height equal to 48, or is the threshold bigger than 60? Sometimes we want to combine multiple factors, like is a temperature below 40 and is it also raining? And any type of Boolean expression that involves the answer to more than one question is called a compound conditional statement. It just means it has multiple comparisons or expressions, and then it joins the answers to both of those expressions together using a special operator called a Boolean operator. A Boolean operator is just an operator that always returns a true or false answer. There's three Boolean operators, and, or, and not, and they're ways of combining multiple bits of data to get one definitive answer. Creating the right algorithm to express your decision-making process can be tricky, but Boolean operators operate logically. So the good news is you've been using these operators, and, or, and not, to make decisions for yourself your entire life. You can apply the same ideas to the algorithms that you create in computer science. Suppose that we have two statements, A and B, and those represent two answers to questions that are being asked in your program. Then the following tables on the next page of your notes explain how Boolean expressions can be combined to answer those two questions using a compound conditional statement. Let's say that we have two questions, and that A is the result of the first question and B is the result of the second question. If we want to combine those two results using the AND operation, in Python we type in A and B. And the rules for evaluating the AND expression go like this. If A, the answer to question number 1 is true, and B, the answer to question number 2 is true, then the whole answer to the expression A and B is also true. If A is true and B is false, then the answer to A and B is false. If A is false and B is true, the answer to A and B is false. And if A is false and B is false, the answer to A and B is false. So the only time you get a true answer using the AND operation is if both of the questions have a true answer. And again, that sounds really complicated when you write it out logically in this kind of abstract way, but let's apply it to a concrete problem. Suppose we're checking to see the answers to two questions. Is A older than B, and is C older than B? That's a question you might have asked yourself in your house or with your friend group sometime, just trying to figure out who's older or how people are related in terms of age. Now notice that the computer can't actually evaluate natural language like is older than. So for the computer, we'd have to store the age of person A and the age of person B and the age of person C as numeric information, and then we could apply the relational operator greater than to those numeric values. So answering this compound question, is A older than B and is C older than B, would look like this if we typed it into Python. We'd say A greater than B and C greater than B. Let's try it out with some different ages. Suppose that person A is 16 years old and person B is 14 years old and person C is 17 years old. If we were trying to see is A greater than B and is C greater than B, what would the answer to that be? Well, A is greater than B, 16 is bigger than 14, and C is also greater than B, 17 is greater than 14. So each of the sub-expressions is true, and in the AND operation, that means the overall answer is true. And if you think about that logically, again, just thinking about a friend group or answering a question kind of that would come up in natural everyday life, your intuitive answer matches the answer that the computer would logically give. So if you were trying to figure out if A was older than B and if C was also older than B, then if A was 16 and B was 14 and C was 17, you'd come up with the answer true. Suppose that we have different ages for the people. Suppose A is 13, B is 14, and C is 17. In this case, A is not greater than B. A isn't older than person B. So this first expression is false, But the second expression is true, 17 is greater than 14. But because we're applying the AND operation, we get a false answer. It's only going to give a true answer if both of the sub-expressions are true. If A is 13 and B is 14 and C is 12, if we plug those into our equation, 13 is not bigger than 14. This is going to be a false answer. And 12 is not bigger than 14, so the second expression will be false as well. The whole expression will be false. And finally, if A is 15 and B is 14 and C is 12, the first expression will be true, but the second expression will be false. The whole overall expression will be false. So in summary, both conditions joined together with an AND operation result in a true result only if both of the sub-expressions are true. Let's look at the OR operator. If we have two Boolean variables, A and B, and those are answers to questions that we're asking in our program, we can combine them together with the OR operator. Note that there might be a typo in your notes here that says AND instead. You want to fix that up to say OR if it's still in there for your version. In Python, we'd say A or B to represent this logic. And we can write down the abstract mathematical rules for evaluating the OR operator, just like we did with AND. If you're evaluating whether A or B is true, you get a true result if both A and B is true. If A is true and B is false, you get a true answer. If A is false and B is true, you get a true answer. And only when both are false do you get a false answer. And again, this is how you're used to using the OR connector in everyday situations. Let's go back to our taller than example. Suppose we want to check to see, is A taller than B or is C taller than B? And remember, the computer can't actually evaluate things like is taller than, so we can use the relational operator to connect them. Let's say that A is 6 feet tall and B is 4 feet tall and C is 7 feet tall. So in that case, 6 is bigger than 4, the first expression's true. 7's bigger than 4, so the second sub-expression's true. And it's true that at least one of those two things is true, so the overall answer will be true. Let's look at the second possibility. What if A is 3 and B is 4? Then A is greater than B, that will be false. If C is 7 and B is 4, then C greater than B will be true. And then false or true is true because at least one of the sub-expressions is true. Suppose A is 3 and B is 4 and C is 2. Then 3 is not greater than 4, that'll be false. 2 is not greater than 4, that will be false. And then because both of the sub-expressions are false, the overall answer is false. And finally, the last scenario we could be in, if 5 is bigger than 4, that's true. Is 2 bigger than 4, that part's false. So the final answer in this last expression will be true because at least one of the two things was true. So in summary, if we have two expressions and they're joined together using an OR clause, the way we saw in our question about heights, if one or both of the sub-expressions is true, the overall expression is true as well. Let's look at the final operation, the Boolean operator not. The Boolean operator not works like this. It only applies to one value. So you'd be saying something like not A. And the not operator, it takes the inverse of a value. So if A is true, then not A returns the inverse value. It returns false. If A is false, not A returns the inverse value. It returns true. Note that the not operation works a little bit differently than the and or the or operations because it only operates on a single operand, whereas the and or operations both have two operands that they connect together. So let's look at some examples. Suppose we're trying to see, is it not true that A is more minutes than B? So it's just a fancy way of saying, is A less than or equal to B? We can write it this way, and sometimes that's more natural when you're expressing an algorithm that you've created. So we could rewrite this as not A greater than B, because remember, the computer can't parse through something like is more minutes than. Instead, you need to store your values of minutes as A and B, and then you can compare them using a relational operator. So let's look at the possibilities of how this might get evaluated. We might have a true answer inside the parentheses or a false answer inside the parentheses. So suppose that A is 60 minutes and B is 40 minutes. So is 60 bigger than 40? That's true, so the part inside the parentheses here will be true. And then when we apply the not operation to it, our overall answer is going to be false. On the other hand, suppose A is 30 and B is 40. 30 is not bigger than 40. This will be false when we evaluate it. And then taking not a false returns a true value. And remember I said that not A greater than B really means that A is less than or equal to B. And you can see that that's the case in these two examples. Here, if we were checking to see is 60 less than or equal to 40, we'd get a false answer. And here, if we were checking to see if 30 was less than or equal to 40, we'd get a true answer. So in summary, the not operation is a special Boolean operator that just reverses or takes the inverse value of an operand. If the operand's true, then the not operator makes it false. If the operand was false, then the not operator causes it to be true.